Hello guys and welcome to my YouTube channel. Today we are going to look at differentiation, a Form 4 topic under calculus. We are going to look at some of the few past papers into brief details. Into details we are going to look some of the few past papers that were done in the past K.C.S.E exams. Okay, we are going to start directly into a brief summary. The statements here states that in general, the gradient function of a curve is given by dy over dx. The gradient function of a curve is given by dy over dx. The dy here, this dy here represents differentiating y, okay? The dy means you are differentiating y, and then the dx here means that with respect to x. So, in general, how to read this dy over dx is that we are going to differentiate y with respect to x. With respect to x means that we are going to differentiate only values with x as their coefficient. We're going to differentiate only values with x as their coefficient. So we have, for example, we are having this value here, y is equals to x raised to power n. Y is equals to x raised to power n. So if you're going to differentiate this x raised to power n here, we are going to multiply by the power first. We're going to multiply this x by the power, and then you reduce the power by 1. What I mean is this: multiply x by n, it will be nx, and then reduce the power by 1, it will be n minus 1. So we have some few summaries also. If displacement s is expressed in terms of t, then velocity is equals to ds over dt. We are going to differentiate the displacement with respect to time. If you are going to find acceleration, we are going to differentiate this. We are going to differentiate velocity with respect to time. Let's look at example 1, question 1. This question was set in 204, paper 1, number 21. It states the velocity v meters per second of a moving body at a time t seconds is given by v is equals to 5t squared minus 12t plus 7. Calculate the acceleration when t is equals to 2 seconds. Here this question is asking us to find the acceleration. We already had the formula of acceleration. That is dv over dt. So to find acceleration, we are going to differentiate. The velocity, okay? So we have acceleration is equals to differentiating the velocity with respect to time. So if you're going to find acceleration here, we are going to differentiate this velocity here. We have our velocity. The velocity is 5t squared minus 12t plus 7. So we're going to differentiate this equation here with respect to t. If we differentiate this one here, where we multiply first the power by the coefficient of t, okay? So we're going to multiply 5 times 2 is 10, then reduce the power by 1. So it will be 10t. If you subtract 2 and 2 minus 1, you get 1. So t raised to power 1 is also just t. And then we differentiate the other value here, that is 12t. If we differentiate 12t, it will be 12. Why? If t here is raised to power 1, if you subtract 1 from t, from that power raised there, you are going to get 0. And t raised to power 0 is nothing, okay? So we are going to have our acceleration equation here as t is equals to, we're going to have our acceleration as 10t minus 12. The question was asking, calculate the acceleration when t is equals to 2. So when t is equals to 2, we just substitute where t is. We replace there, we substitute 2 there. So in our equation we have 10t minus 12. If we are substituting 2 here, it will be 10, t is 2 minus 12. This one will give you 20 minus 12, which is 8 meters per second squared. 8 meters per second squared. That is acceleration. Remember to write the Remember to write the unit for acceleration. Remember to write the unit for acceleration is very important. The unit for acceleration is very important. Let's proceed to question 2. Let's proceed to question 2. So the question 2, it was a 205 question. Question 2, it was a 2005 question. Okay, it states, a stone is thrown vertically upwards from a point O. A stone is thrown vertically upwards from a point O. So, when a stone is thrown vertically upwards from a point O, okay, after t seconds, the stone is s meters from O. Given that s is equals to 29.9 t minus 4.9 t squared, find the maximum height reached by the stone. Find the maximum height reached by the stone. So here we have the displacement s. We have the displacement s. We are going to find the velocity here. We don't have velocity because at maximum height, the velocity reached is 0. Where at maximum height v is always 0. Okay. So we first find our velocity, then we substitute with our v there. Okay, so let's proceed. So we have our velocity, we have displacement, so we are finding velocity. Velocity v is equals to differentiate displacement with respect to time. We are differentiating displacement with respect to time. So we have our displacement there. We are going to differentiate, that is 29.9 t minus 4.9 t squared. This is what we are going to differentiate with respect to t. If we differentiate 29.9 t, it will be 29.9 because the power will be reduced by 1 and t will be raised to power 0. We are going to subtract. We differentiate 4.9t. It will be, you multiply 2 times 4.9, 2 by 4.9, you are going to get 9.8. Okay, and then t, if you reduce the power by 1, it will be t. So this one is our velocity. This one is our velocity here. This one is what we are asked to find. Okay, and then the question proceeds that at maximum height, find the maximum height reached by the stone. So at maximum height, the velocity is always equal to 0. At maximum height, the velocity is always equal to 0. So we equate this equation here to 0. That is 29.9 minus 9.8 t is equals to 0. So we are finding, let's find t. Let's find t. So what do we do here? You take 29.9 the other side, it will become a negative. So we are going to subtract 29.9. Okay, the other side here on this our left hand side we are having negative 9.8 t is equals to, on our right hand side we are having negative 29.9. So t will be equal to 3. You divide both sides by negative 9.8 to remain with t on this side. So we have our time is 3. So back to displacement, replace t with remember the question was asked, find the maximum height reached by the stone. Find the maximum height reached by the stone. So this is our time that the stone reached the maximum height. So we have the displacement was 29. The displacement was 29.9 t minus 4.9 t squared. We have t as 3. So you just replace it to this equation here. It will be 29.9 multiplied by 3. You are subtracting 4.9, 3 squared. Remember t is the one that is squared, not 4.9. So we are going to multiply by 3 squared. This one here we are going to have our, so we were here We have 29.9 29.9 multiplied by 3. We are subtracting 4.9 multiplied by 3 squared. So we are having our answer as 45.6. We are having our answer as 45.6 meters. That is the maximum height that was reached. It is 45.6 meters. So this one was the maximum height that was reached by the stone. This was the maximum height that was reached by the stone.